Good afternoon. So I'm going to talk to you about diagnostics, particularly focusing on schistosomiasis. So the ambitious goals set out by the WHO to eliminate several NTDs by 2030 do not have a clear strategy for diagnostics to achieve those goals, with lots of emphasis on treatment interventions. Also, the lack of diagnostics tools really limits surveillance data, with true prevalences in certain countries unknown. So there's a real need for improved diagnostics to guide decisions on interventions and to provide tools for surveillance post-elimination. So many in the room will know that your diagnostic characteristics change as you move through a controlled program. And as you reach elimination, your diagnostics need to be highly sensitive and specific. And to find balancing act between sensitivity and specificity and the cost and technical ability or simplicity of that diagnostic. And there's several criteria set out by the WHO in terms of the ideal diagnostic for NTDs in endemic settings. And it's a big ask to fit some of these criteria together. And another big criteria for these diagnostics is accessibility, in terms of the availability, the affordability, the acceptability, and also the appropriate use and quality control of those diagnostics. And here I'd just like to point you to a webinar that was streamed on Tuesday by the ISNTD. We're really focused on diagnostics for schistosomiasis and accessibility of those diagnostics. So do look at the re-recording of that to find out more information. So there's four main categories of diagnostics that can be developed or used for schistosomiasis, including microscopy, antigens, molecular and antibody tests. And these can be used at different stages of control to support decision-making within the control programs, such as stopping MDA, moving towards more selective and individual treatments, when and how to certify transmission interruption, and how to monitor resurgence. And over the next few weeks, the WHO is planned to publish the target product profile for diagnostic for schistosomiasis, which will help to guide some of the development and implementation of those diagnostics going forward. But we know that schistosomiasis is a highly complex disease. We have two main forms, intestinal or urogenital, which present different morbidities and different ways of diagnosis. We also have the Snell hosts, which allow for prolific amplification of the parasites, which can lead to rapid resurgence. We also know that in Africa, we have animal reservoirs such as monkeys and rodents, which will need to be thought about towards the end stages of control. And in Asia, we have the zoonotic species, which really do hamper control and interventions. So the roadmap really acknowledges that diagnostics exist for schistosomiasis, but major modifications are needed to achieve those goals. We need point of care diagnostics that are sensitive and specific. We need molecular tests for xenomorphology and surveillance, and we need good diagnostics for the genital manifestations. This just shows you some of the prime diagnostics available for schistosomiasis. Some are commercially available and some are just used as research. But just to point out here, the big push to develop the RDT based on the CAA antigen through strong partnerships with FIND and Leiden. And this is to target all species of schistosomes using fingerpick blood as the sample, and to allow the development of a highly sensitive diagnostic to support MDA campaigns and reassessment mapping. And again, on Tuesday, this was presented by Sarah Nagura for FIND about the plans for the next few years for the development and implementation and testing of that diagnostic. So do look at that recording for focusing on CAA. So I'm particularly interested on development of molecular diagnostic tools, particularly the isothermal methods, as these are portable and have great potential for being implemented in the field and for point of care testing. And I'm particularly interested in looking at an isothermal called RPA, and it's highly sensitive and specific and rapid and has great potential for portability and point of care use. We're particularly focused on developing good ways of sample prep and which sample to use. We use dried formulations which are field tolerant and ported devices to actually detect amplification of the DNA. We get rapid results in very short times. So just to show you some of the data very quickly on that. So this is a study on urogenital schistosomiycosis in Zanzibar in partnership with Charlie and Steffi, showing high sensitivity and specificity of the diagnostic. And then again, a study on FGS in partnership with Amaya at the London School and Lizette at Leiden, showing high sensitivity again for on lavage samples and also self-swab vaginal samples, allowing and developing a point-of-care diagnostics for FGS. And just to go back to some of the data on the urogenital study, just to really show you where we're targeting this diagnostic. We're targeting those really low infections where microscopy starts to become very insensitive. Looking at samples where we have very few eggs from 1 to 5. And again, we have good sensitivities there up to 91% with those really low and ultra low intensity samples. So great potential for future work. And we really want to move this kind of diagnostic forward to support and maintain elimination and also provide point-of-care diagnosis for FGS and also to reduce stigma for FGS. We want to try and allow targeted diagnosis and treatment, facilitate test and treat, reduce treatment fatigue and also allow more tailored diagnostics. Also, not just restricting this to RPA, but also LAMP and also some of the portable qPCR technology. We're also really focused on developing tools for snail xenon monitoring, developing molecular toolkits to be able to identify schistosoma species within field samples and increase sensitivity of our snail monitoring methods. Developing methods for pooling snails so we can increase the throughput and reduce the labour and the costs involved in those highly laborious techniques currently needed for snail monitoring. And also colleagues at the museum are highly focused on looking at environmental samples, how they can develop methods to detect transmission within water samples. And this is being led by Fiona Allen and Aidan Emery at the Natural History Museum. So just to bring this to a close, it's really clear that there's high diagnostic needs for many of the NTDs. And it's going to be harder. These are going to be needed as we move to very low levels of infection and prevalence. Development of these diagnostics really takes time, so we need to make sure we have enough commitment to actually move these diagnostics forward now before we reach some of those end goals. And just to finish off, I'd like to thank my colleagues and collaborators, particularly the students at the London School that were involved in the RPA work, and also collaborators and partners in various countries involved in the work.